electrochemistry, right, and electrolysis. But before going to problem solving, we need to recap, and review a little difference of electrochemistry and electrolysis. It's related to electrochemistry and electrolysis problems, right? So we go back to the basics. Okay. So what is electrochemistry? Anybody? Electrochemistry, guys. This is okay, like that. So this electrochemical reaction, okay, meaning to say it uses the chemical reaction to produce an electricity. Okay, what do you mean by this? Meaning the chemical reaction will proceed by its own, okay, without adding any electrical device, meaning spontaneous reaction. Okay, for example, if you put a chaos solution, a zinc sulfate, okay, and the other one also an aqueous solution of a copper sulfate, something like that. So even if you will not put, okay, a battery or any electricity device, then it will generate electricity, okay, through the two aqueous solutions involved, the zinc sulfate and the copper sulfate. Okay, it's gonna be like that. So I will show you an illustration for that. Spontaneous reaction to produce electricity. Okay, meaning to say natural or reversible chemical reaction without adding anything or without inputting energy. Okay, it will just proceed by its own to produce the product and go back to the reactant, go back again to the product and go back to the reactant. That's why it is called a reversible reaction, a reversible chemical reaction, meaning to say proceed the reaction by its own, meaning natural. Okay, and the arrow will be like this, going to forward reaction, and there's another arrow going back to the reactant. It's a reversible reaction. So that is electrochemistry all about. Okay? So again, using chemical reactions naturally to produce an electricity. Okay, something like that. You get the point? Okay. Some of the devices are just like that. Okay. And any gadgets are all like that, or mostly are like that. Okay. Or if not, some are like that. Okay. So I need to illustrate. It's gonna be like this. Oh my gosh. Oh my gosh. Okay guys, just understand the basics. Okay, so it's gonna be like this. If I have, gosh, A and B, right? If I have A and B substance, or shall we say metals or non-metals or whatever, true. Let's say A, okay, A, ganun. So A, this is A. Okay, A. Okay, A substance. Okay, and then this substance will transfer electrons to B, something like that. Okay, like this. Transfer electrons to B. Okay, ganon. Okay, so here's the electron being transferred. Okay, something like that. Okay, so understood that A has a higher number of electrons and B has a lower number of electrons. That's why B needs more electrons. Okay, so the transfer of electrons from A to B, okay, without adding any devices or without adding any energies or external energy or whatever. So this is spontaneous reaction. Okay, so this is an electrochemistry. Okay, electrochemistry. Okay, something like that. And then, in order the electrons to move properly and freely From A to B, we need to input and to put a path. Okay, so that the flow of the electrons are proper and steady. So we need to introduce a path known as a wire. Okay, wire or a cable. So that's a path in order for the electrons to move freely and to flow freely and to be transferred freely from A to B. So that's the concept of electrochemistry. So in this, okay, gonna be like this. Okay, ganon. Ganon. So electrons here, blah blah blah, so on. So it's gonna be like this, the illustration now. Okay, in order to have a proper flow of electrons, then we need to introduce a path or a wire. The straight lines here represent the path and a wire. So in here, there will be a proper and smooth transfer of electrons, okay, movement of electrons or flow of electrons. So if there is a flow of electrons, movement of electrons, transfer of electrons from one point to another point through a path or a wire, then we have an electrical energy known as an electricity. Okay? So if we define technically electricity, we said transfer of electrons or movement of electrons through a path or specifically a wire or a cable, something like that. So then electrical energy will be generated and produced. Okay, so this is electrochemistry. Yaman. So A and B really were B transferring and accepting, transferring and accepting. It depends on the situation. Which of them is having the property of weak pool of electrons and strong pool of electrons. Of course, the weak pool of electrons need more electrons. Okay, by common sense. And the strong pool of electrons no need of additional electrons. So we can say that the positively charged particles, remember this is a reverse. If the substance is a positive charge that contains more electrons. Wow. Okay. If the substance or an element, or shall we say non-metals or whatever what you choose, if it has a positive charge, positive, the more it has a electron, right? It's the reverse, right? So the more it is a negatively charged, the more it has a less electrons. Okay, that's why we have the positive terminal. The positive terminal in a battery is an anode, and the negative terminal of the battery is a cathode. Okay, it's reverse, since we know in the first place that anodes composed of a negatively charged particle or negative charged ions, and then why it is a positive terminal. Okay, it is a positive terminal because it is a region in which it is going to transfer the electrons to the other side. Okay, then it will become positive. As you transfer the electrons all the time, that region will become more positive, 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 positive. That's why it's called a positive terminal, the anode. Okay, even though anode composed of a negatively charged particles, okay, or negatively charged ions, okay, like that. And then the cathode is the reverse, so it is really the negative terminal. Imagine cathode composed of positively charged particles and positive charged ions. Then why it is called a negative terminal? It's a reverse, okay, because it is accepting more of the electrons. That way it becomes negative terminal. Okay, but from the start it is still a positively charged particles without the transfer and movement happening. originally in its initial state. That's why it's called positively charged particles or positively anions or ions, okay, without any movement pa siya. Okay, that's why it is cathode. But during the movement and transfer, okay, it will become a negative terminal. Okay, because it keeps on accepting negative electrons, okay, from the anode. So this is the reverse, right? Okay, so be careful also with this, huh? Okay, so the more it has a positive charge, okay, like this. For example, positive free charge of iron, okay, iron for example. So this has more electrons to be transferred, okay, to the negative charge. So the negative charge really has a less number of electrons. Be careful, okay, because if you see negative, that's automatically an more electrons because it is negative. It's not. Okay, so this is the power of uh, theory and principle. Okay, because it is talking about the transfer and accepting na siya talaga. Okay, now anode. Okay, I discuss a little bit so that we can understand in the problem solving, because it is in the problem solving the application of our learning and understanding. So if we don't really learn and understand the basics and the concepts, then we cannot solve properly. Something like that. Sapit ang dila. Okay, so anode. Sorry guys, I'm not an American. Anode is a negative, positive terminal. Okay, positive terminal. Cathode is a negative terminal. Okay, okay, like that. Okay, anode is the positive terminal. Okay, cathode is the negative terminal because the cathode, it is where it will always accept the electrons. So the substance there will become highly electronegative. That's why it's called the cathode. Okay? And then the anode is positive terminal because the substance there are being transferred the electrons, the more it is become positive. So that is called positive terminal. Okay? But by definition, it's the reverse because the anode composed of negatively charged particle ions. Okay? And the cathode composed of positively charged particle, okay, ions also. Positively charged ions. Okay? Know the difference. Okay. And another reverse also in this principle is the talking about the agents. Agents. Okay. Basically, the redox really is, shall I say, very confusing theory concepts in general chemistry lecture, and you have to really to dig it out. Nging ana, why it happened like that. So, so that we can really understand in the redox equation because basically electrochemistry applying the redox chemical reaction principles. Redox meaning reduction and oxidation. Now, it's also a reverse. Now, if the process undergo an oxidation, normally the substance is being oxidized. Now, that process is being undergoing a reducing agent. Why? Because it reduces the other substance. Okay, that's why it is a reducing agent, even if it undergo an oxidation process. Now the reverse holds true. If it is a reduction, normally the substance is being reduced. So that is called an oxidizing agent. Okay, because it reduced the other substance. Something like that. Okay, be careful also. Meaning oxidation, reducing agent. Okay, reduction, oxidizing agent. If we speak oxidizing agent, so that means it is being reduced. Okay, reducing agent, that means it being oxidized. Ganun siya. Okay? Now, in this also topic, we need to remember, guys, the nomenclature in order for easy understanding for the concepts, and you have to memorize the clues. Okay, the clues CLUES or the hints HINTS. Okay, Now, we need to remember an ox. Ox is an animal, right? OX. And we need also to remember a red cat. Iring. Okay, a red cat or pusang pula. Okay, red cat. So we mean a red cat. So meaning reduction, of course, in the cathode. Red cat. Meaning oxidation occurs in the anode, an ox. So you have to have abbreviations so that you can really memorize, understand very well. An ox and a red cat. Okay. And another identification also, the low ox and the rega. Means the low ox meaning there is a loss of electrons. We are referring to the electrons there. Low ox and a rega. Meaning gain of electrons as well. Rega. Reduction, gain of electrons. Rega. Low ox, loss of electrons. Oxidation. Okay, so we need to memorize the abbreviation so that we can understand easily something like that. Okay, you understand the point now? Okay, now in this also topic we need to understand the electrochemical cells. So what do we mean by an electrochemical cells? The electrochemical cells are composed of an oxidation cell or an anode cell plus the reduction cell or a cathode cell. Okay, something like that. So the electrochemical cell has its own cell potential. What do you mean by cell potential? It is the voltage occur in each cell. Voltage value in terms of volts. VOLTS, and this is also known as the electromotive force or the EMF. Now, in general chemistry lecture, if we talk about potential, that would mean automatically as the voltage of each cell. Okay, for example, the potential of chromium is like this, that automatically the voltage, okay, without question. I am just teaching you with the familiarization of the terminology involved because in problem solving it is not literal and word by word all the time. Okay, so if we mean potential, meaning that is a voltage. We meaning potential difference, that is the difference between two voltages involved in a particular chemical reaction to produce an electrical energy or an electricity. Ganon. Okay, know the basics first before problem solving in electrochemistry. Okay, it's gonna be like that. Now guys, if we have the potential difference, we can say really by technical theory in this topic that it's gonna be a high electrical potential minus the low electrical potential. Meaning to say the high value of the voltage minus the lesser value of the voltage, that is the potential difference. Okay, it is not the same as what we call as the cell potential because the cell potential is not the difference. Okay, it's not the difference, but rather it is an addition of the two half cell reaction voltages in which you need to reverse the other one. Okay, normally you need to reverse the other standard reduction potential value. Okay, nakakaloka no, di ba? Okay, or you can simply say the potential cell or E cell. Potential cell is E stands for electrochemical abbreviation only. So E cell or electrochemical cell potential is equal to the potential of the cathode, something like that, okay? And then to be subtracted by the, what is subtrahend in mathematics? I forgot the term. Subtrahend, ano ba yun? Nakalimutan ko siya. Okay, let's just go simpler. Okay, the E cell or electrochemical cell is equal to the E anode minus E cathode. Okay? Like that. Remember that one, huh? E anode minus the E cathode. Okay? Meaning to say the anode is the high electric potential, right? E anode. Okay? Remember? So the flow of electrons to produce an electricity is always from the anode to the cathode. Okay, it's always from the highly negative charge ions or particles to the, okay, positively charged particles or ions. It's gonna be anode to cathode, blah blah blah, so on. So starts from the negative to the positive, something like that. Okay, in electricity or electrochemistry, something like that. Okay, later we will solve a lot of problems, not a lot, only four. Okay, so we have now an idea for that, and now let's go to the non-spontaneous to produce an electricity. Okay, meaning to say it will proceed by having a device to produce an electrical energy through chemical reactions again. Okay, meaning a device was used to produce an electricity through chemical reactions. Okay, so the more I make slow in discussion or I talk slowly, the more my tongue will be twirled. Really, if I talk very fast, my tongue will not be, interrupted. Wow. Really, okay, if I can talk, I will talk very fast, or not too fast, my tongue will not be interrupted. Okay, but if I talk very slow, my tongue will be twirled. Okay, something like this. It's my nature. Okay, when I talk or when I communicate in English language. Okay, something like that. That's why I need to talk fast a little bit during my discussion. Okay, if I have to make it slow, then something wrong with my tongue. It's the reverse. Okay, so ito pa, non-spontaneous reaction the way I talk, right? And spontaneous talaga. Hindi siya ma-reverse. Okay, ganun siya. So, if we have the electrochemistry, we have the electrolysis. This is now the electrolysis. We use devices such as the Voltaic cell and the galvanic cell. The example of Voltaic cell and galvanic cell is a battery in which you need to put that in a wire to produce an electricity in order to light the fluorescent and in order to light the bulb, the incandescent bulb. So this is an electrochemistry already because this is a non-spontaneous chemical reaction. Okay? We need to produce an electricity by non-spontaneous because it doesn't proceed by its own. We need to add energy, and the energy we use this is an electricity. Okay, electrical energy, something like that. So this is electrolysis already. Okay, so meaning to say using an electricity through chemical reaction or to create a chemical reaction to happen to those chemical processes that doesn't proceed by its own. Okay, not natural, unnatural. Unnatural meaning I-N-N-A-T-U-R in English, meaning the opposite of natural. Okay, unnatural. Okay, something like that. Okay, so it's gonna be like that. So that is electrolysis na siya talaga using galvanic and voltaic cell, which is a battery that has again a positive terminal and a negative terminal. Okay, so that's electrolysis. Now we understand already electrolysis and electrochemistry. Okay, an electrolysis example, guys, is to add hydrogen gas and oxygen gas to produce water, and then you have to put electrode, something like a metallic electrode, and then there's a battery that you will put somewhere along in between for the two samples, something like that, and it will create electricity through that. So that is electrolysis. Okay, not natural, right? Because you do something, okay, to produce an electricity. Okay, but whereas the natural one, we don't add device to produce an electricity. It's very clear, right? But still, again, using chemical reactions, of course. Okay, so this is electrolysis and electrochemistry. Okay, so this electrochemistry and electrolysis are what the world made us produce light energy. And this is the reason why we have the mobile phones operation, gadget operations, laptop operations, appliances operations, television operations, power producing devices. So we have light, we have electrical energy, and we have gadgets to use. Without these principles, then we don't have mobile phones to operate. Okay, we don't have communication all over the world without this theory. Okay, these two theories are being used in gadgets and technology to produce power. Without this, we don't have light now. I cannot do my vlogging now without this electrochemistry and electrolysis because this is the theory behind producing electrical current and electricity. Always electrolysis and electrochemistry, and also the laptops and the gadgets operation. Okay? Or else your phone will not be on without this theory. Okay, because it has metals in the microchips inside your mobile phone, and it undergoes chemical reaction inside your mobile phone and inside your laptop. You just don't see it, but it performs a chemical reaction inside your gadget. Understand the point? Okay, so we imagine in that. So there's an electrochemistry and electrolysis in it. Okay? Very clear. Okay? Now, we need to solve 4 problems for that. Okay? The first problem, but before that, of course, we need to know who are the people behind of these discoveries, right? So this is discovered by Michael Faraday in 1800s. So Michael Faraday, his contribution to science are all about electrochemistry and electromagnetism. Now I'll be able to discuss what is electromagnetism all about. Okay, it is a science of charges involved. Could it be a positive charge and a negative charge? So it involves forces, charges. Okay, for example, if a large charge of the chemical reactions and that or whatever, this is a study of Michael Faraday. Okay, he is a scientist. That's why the electrical charge occurs because of him, because we need to use the Faraday constant, which is equal to 96,485 coulombs per electrons. Okay, grabe, per mole. Okay, why we arrive this? Because we have also the value of the electrical charge through the formula of the Coulomb. Okay, discovered by Mr. Coulomb. Is also a scientist, which is equal to 1 electric charge is equal to 1.602 times 10 to the negative 19 coulombs. Sabi na naman nila. Okay, negative 19 coulomb. And then why we arrive 96,485 coulombs per mole electrons? Because we need to multiply that to the Avogadro number, which is equal to 6.023 times 10 to the 23 per mole, something like that. Then, if you are studying chemical engineering or, BS chemistry or engineering course, you have to memorize this. Okay, because it will become out in the examination also, in the future examination under electrochemistry and physical chemistry, all about electromagnetism, electrochemistry, and electrolysis, something like that. So the contribution of Mr. Michael Faraday is somewhat similar to this Mr. Coulomb about electricity, chuba chuchu. Okay, but in Michael Faraday, he studied more because he studied also with diamagnetism. Okay, diamagnetism meaning a weak magnetism in which used an orbital motion by an external magnetic field. Okay, non-uniform magnetism or non-permanent magnetism. Okay, and there will be a repulsive force out of it. Okay, this is gonna be diamagnetism. If we have diamagnetism, we have also electromagnetism, and we have electrolysis. So these 3 terminologies are the focus of Mr. Michael Faraday as a scientist in his contribution somewhere in 1800. Got the point? So you should also memorize that one. That's a trivial question or theory question in future examinations. It's gonna be like that, okay? Now, there's also another scientist that's related to that. It's gonna be the Maxwell. Okay, I think that's Mr. John Maxwell. His contribution, guys, is all about, again, electromagnetic but through radiation. And he tried to correlate the relationship between the electricity and the light, okay, and the electromagnetism. Okay, light, electricity, and the magnetism. So it's related to Michael Faraday contribution. Okay, and also related to Mr. Coulomb contribution in electrical charge. Now, guys, we are having the problem solving now, and we need to understand also the basic practical electricity equation and formula by the Ohm's law. Voltage is equals to current times the resistance. Okay, power is equals to work over time, something like that. Power is equals to current times voltage. Power is equals to the charge, small q, times the voltage. And then current, A, is equals to the charge q over the time. Okay? Now, 1 coulomb is equals to ampere second. This is related to time because the problems are usually dealing with time, where the charges passes through that solution. Okay, solution, what is the electricity obtained there, what is the charge obtained there. Always time, and you can feel that that is an electrolysis or an electrochemistry problems, because it's always mentioned there, the time passes through the anode, passes through the cathode. So you have an idea already. This you're gonna be applying the formulas of Ohm's law, electrical charge of Coulomb's law, and with the combination of this Mr. Michael Faraday. Okay, like that. Now, since we are having the discussion last month with the thermodynamics, then the thermodynamics also will be correlated and linked with this also, especially the Gibbs free energy. Why? Because this gives free energy is an internal energy, and then we need to exert energy, as what I mentioned earlier, so that we can have an electrolysis chemical reaction. Without energy, there will be no electrolysis. Okay, because you add energy, you input energy in it, aside from the heat energy and electrical energy. Okay, we need to input the Gibbs free energy. Okay, now I need to introduce the basic formulas that we will be able to use in our problem solving so that we can relate that there. Okay, so I need to introduce the basic formulas first. Okay, before going to problem solving, because it's in these formulas and equations that we will be analyzing what is the best and what is the appropriate formula and equation to be used, to be, utilized in those problems that I will be able to present later on. Okay, very clear, right? So anybody can understand my English language or English communication, then interrupt me for a while, then I have to, I have to elaborate more. I adjust, I make it slow now, okay? Because before I'm very, very fast talking. That's why, okay? Okay, guys? Okay, the first formula for this is, okay, the Nernst-Simon equation. Oh my gosh. Based on my additional research, aside from my learning in my college education as a BS Chemical Engineering graduate and a licensed chemical engineer, okay, I researched a lot pa. Okay, because I still have to learn more. Okay, something like that. In order for us to share an information and also so that I can have a content in my YT channel, of course. Okay, how can I have my content without research, without reading a lot, something like that? So I should do this. Okay, so first, gives free energy. Charot. Gives free energy is equal to, charot. Okay, the Gibbs free standard minus the universal gas constant times the capital T temperature, Ln. What is the partner of Ln here? Okay, it's gonna be the Q. Okay, okay, like this. So now we let the Gibbs free standard equal to 0. Okay, if it is equal to 0, meaning we let that as a reversible chemical reaction. Okay, so it works for reversible chemical reaction, letting the Gibbs free energy standard. Standard, guys, there's a 0 at the top of the capital letter G or any a letter represented. Some, for example, enthalpy, capital H, with small circle at the top that is at standard temperature at 25 degrees Celsius or at room temperature. Okay, so if we let delta G is equal to 0, so it will become now delta G automatically negative R T ln Q. Ganon. Okay, like this. Ganon siya. Okay, guys. Ito oh. This one. This is the delta G. Okay? Gives free energy. Okay. But in relation to the Faraday study or the electrochemistry or electrolysis, we have another equation. Delta G is equals to the negative N. What's N class? The N class is the number of electrons being transferred from one point to another, or from anode to cathode, or from the oxidation process to the reduction process. Okay, that's small letter n. That's not the same with the standard small letter n that we familiarized with. That is the number of mole. Okay, but in here, in electrochemistry special topic, we treat the small letter n as the number of electrons being transferred. Okay, small letter n. Okay, ganon. Times the Faraday constant. Okay, the Faraday constant. Okay, ganon. Faraday constant is capital F. Okay, what's ganito? F is equals to 96,000. Okay, column over mole dot or times electron. This one. This is the unit of our Faraday constant. Okay, F. And then times the capital E. Capital E, as what I've told you earlier, this is the cell potential or electrochemical cell potential, in which you can obtain this through the standard reduction potential given in the table in the Paris Chemical Engineer's Handbook, in the chemistry book, in the physics book, or any science reference book, or it could be you can Google that one, the online. Okay, you search that and type that one, SRP, Standard Reduction Potential of various ionic substances, metals and nonmetals, then bingo, you can have an electrochemical cell potential value. Okay, that's very clear again. Okay, so delta G is equals to negative N times F times E, like this. Okay, so 2 na. We have now 2 value of delta G. Okay, ganon. Okay, so we have also the formula of Arrhenius. Okay, you remember we derive the Arrhenius equation. It starts from the rate constant T is equals to the exponential raised to the power negative delta G over universal gas constant R times the capital T. Okay, that is the rate constant. Now, why the K appear? Okay, the K appear in substitute of Q because K and Q is directly proportional with each other here. Q here is the reaction constant, meaning product over the reactant. Since we are not dealing here with chemical reactions plainly, we are dealing here with redox equation, then our product is specifically the reduction process over the oxidation process. Since what being occurred in the reduction process is your cathode. So it will be cathode over anode. Okay, that's very clear. Okay, cathode over anode. And that is your Q as a reaction quotient in the electrochemistry and electrolysis problem solving involving redox equation plus the anode cathode charges chuba chuchu. Okay, you can understand. You can feel the problem really as we go over. Okay, ganon. So, muna sinita po. Okay, so let's Q, capital Q is equals to the cathode over the anode. Okay, anode. Okay, like this. Okay, guys. And then it is expected, guys, that you are mastering now the oxidation and reduction half reaction, huh? Okay, how it works. Because you can never solve these problems if you never understand oxidation and reduction, how it works. Okay, like that. The one I told you, the rega, the low ox, okay, the anox, the red cat, like that. Okay, the hesua, the WPA, okay, like that. Understand? And the lesra, the SPE. Okay, lesra, meaning less cell potential, strong reducing agent. Now that is a strong pool of electrons. Okay, guys, if it is has a very low value of a charge or a voltage, that is automatic the strong pool of electrons, ha? And you will put that in the oxidation, sorry, in the reduction cell. Okay, as I told you earlier, this requires a little bit of confusion really if you cannot understand how it works. Okay, something like that. Okay, and then the oxidation reduction potential, guys, it's expressed in the reduction reaction, and you have to take note that you have to reverse the other one so that it would compensate the reaction, because all are given in the standard reduction potential. There's no such thing in the book that states standard oxidation potential. It's always oxidation reduction potential. Then how can you add those voltages if you will not change the other side? Okay, then you always change the oxidation process. You need to determine really what to change, like that. Normally, you change the weak pool of electrons, something like that. Okay, and you have to, as we go along the way, we can understand really. Okay, question number 1. Charot! Electrochemistry problems or electrolysis. Okay, ganon. So, how long will it take in hours for a current of 745 milliampere to deposit an 8.56 gram chromium into the cathode using solution chromium? It looks like difficult, right? If you try to hear the terms, it looks like difficult, but it is also simple to solve if you are really following the formulas and equations, the theories and concepts of electrochemistry. So here, the time is being asked. Okay? Like this. Igutom ko. Charot! Nakaloka. Igutom ko, guys. Mukhaon sa ako. Let's stop for a while. Let's say 5 to 10 minutes. Igutom ko mukhaon ko something. Charot! Banana, potassium, and calcium. Right? Okay. Wait for a while. Oh my gosh. Okay. Ganon. So, potassium and calcium found in banana, this can develop for the strong bone. Okay? And then, this has positive charge. Meaning, it has more electrons to be transferred to produce electricity inside our body. Because human being has an electricity source. Okay? Then, we have also an oxygen through drinking water. Oxygen polarity is very high. It has a -2 charge. Then, the positive charge of those potassium and calcium will be transferred to the electrons of the oxygen. Then, bingo, we can have electricity inside our body. You get the point? So, that's why I eat bananas, so that I can have an electrical source inside my body. Because if the human body has no electrical source also, we can do our work because it produces also energy. Okay, because energy is not limited to carbohydrates or calorie intake. It's not limited. It's also a lot electrical energy, mechanical energy, chemical energy, a lot of types of energies around us. It's not only limited to one type of energy. So we have also electrical energy inside our body. Okay? Though it's not expected to be high, of course, but at least we have. You get the point? Because of the polarity issue and the law of magnetism inside our body. You know, the law of magnetism is not applicable only in the metals, in the, in the material, but it's also applicable inside our body. Okay, so that's why we need to know the chemistry of our physiological chemical reactions through different biological substances that we take inside our body. Okay, and this a relation to that also with our, our outlet, okay, inside the body, which is the free radical, as I teach you over and over again. If we have too much free radicals inside our body, the unpaired electrons of oxygen, the more the viruses will come inside our body. Ha, di ba? Okay. Ganon siya katindi. The more we have an outlet for the virus to come in because we have too much lone pairs of oxygen that is not completely shared with those other substances in our body. And that time, this oxygen will destroy the cells and tissues of our organs. Now, we will become weak. Okay? So our immune system will become weak. Now, diseases will come in. Okay? Through this bacteria that will come in these free radicals inside our system. The order to develop and stabilize our free radicals outlet is to drink or to eat more nutrients, especially rich in vitamin C, okay, and rich in vitamin D, okay, because it will react to our antibodies to fight those microbes and viruses so that it cannot enter inside our system, okay? So that's why we need to eat more fruits and vegetables, okay, or any multivitamins or supplements if you want, okay, something like that, okay, to crack or to destroy the free radicals, okay, because the enemy of these free radicals are the antioxidants, and fruits and vegetables have a very high content of antioxidants that can protect and preserve our cells and tissues in our organs inside our body. Okay, so in that way, we can prevent diseases to come in. Okay, so that is now epidemiology, the controls of diseases to prevent it to occur in our body. So in order to understand more the epidemiology, we need to understand the chemistry involved with these biological substances and chemical substances, because most of the medicines are composed of biological substances and chemical substances through its formulation. Okay? Ganon. Any questions so far? So it's also related to electrochemistry, right? A bit lang siya. I'll try to connect because I'm eating banana now, rich in potassium and calcium and magnesium also as well. But potassium is the high content of banana, okay? And these minerals are nutrients in order for us to become strong. Okay? Ganon. Makaluka. Igutom ko yaw-yaw. Okay, guys? Okay. Wait. I have to finish this banana first. Okay. Even though you will eat banana a day, it's enough also even though you will not eat rice, because banana also rich in carbohydrates. There is CHO present in banana. If you try to get the sample of the banana in the laboratory, you can obtain percentages of carbon atoms, hydrogen atoms, and oxygen atoms. You cannot just see that in your naked eye, but if you try to break that in the laboratory through sampling, then you can have the amounts of carbon, hydrogen, and oxygen. And this can create energy because it can convert to sugar. Okay? More of the sugars are complex components of carbohydrates. Okay, the monomers plus another monomers, it will become a polymers, and polymers are substances of carbohydrates, and those, the ganon, the hydroxy ribose, okay, the triglycerides, the glycerols, the glycerides, sucrose, fructose, maltose, lactose, ganon. You need to understand that also in the study of biochemistry or biochemical engineering. Okay? Very clear. But we cannot discuss that here because our topic is electrochemistry. Okay, but I just try to read because I'm eating. That's why. Okay, guys? Ganun siya. So every action you move, you need to consider science and chemistry, okay? Talaga siya para aware ka talaga, okay? For example, oh, I touched this one. It's a bacterial action. Okay, like this. You have to consider the germicidal action, the bacterial action, the fungicidal action, okay? The viral action, especially for the viruses. You need to troubleshoot the behavior. Okay? You need to study theoretically what's the behavior of those living organisms. They are called living organisms. Okay? Those bacteria, germs, microorganisms, microbes, they are all called living organisms. Okay, and in fact, we are also categorized as one of those living organisms, but in a macro state of view. Macro meaning big. Okay? So just like macromolecules, we have also micromolecules and we have also macromolecules. Okay? The study of biochemistry is just like that always. Okay? And this is the point. And then this living organism will interact with each other to the environment, in the ecology. That's why we have ecosystem. Okay, the interaction of living organisms to the human being or to the living organisms and to the plants and the animals like that. That's ecosystem. Okay? This is study of environmental science also, but you have to understand all of the basic chemistry of the environment so you can understand what is the interaction level. Okay? Ganun siya. Okay? My gosh. Going back. Sorry guys, time check brought to you by powdered Alaska milk is already 52 minutes 31 seconds. The time elapsed during my live streaming. Oh my gosh. Do we go mag-solving? I don't know if you're gonna have mathematics. Okay guys. I drink water again. Water has a high polarity because of the negative charge of oxygen plus the positive charge of hydrogen. Okay, it adds also electricity inside our body. Ganon. With tagalihok, natural chemistry, right? Every move we take, every move we make, we always surrounded by chemistry. Okay? Like even though we don't have money, but we are surrounded with chemistry already. Okay? Because without it, we cannot breathe. Okay? Because oxygen is always around us, and oxygen is the study of chemistry. Okay? Oxygen plus nitrogen is equals air. Okay? Something like that. So we need to be smart enough to remember the basics of science. Okay, now going back to the problem solving, how long will it take in hours for a current of 745 milliampere to deposit 8.56 grams of chromium onto the cathode using a solution of chromium chloride? The first thing to do is to write the given and the data. Oh my gosh. Talaga? Yes, problem solving steps. Systematized steps, right? Or sequential method of solving problem. Okay, ganun siya. In order for you to pass certain examinations, then you have to be systematized on how you solve problems. Okay? It's not like that only, and you cannot understand well, and then it will confuse you. Okay? Everything has to be done in a proper way or proper order, just like us. Everything to be done in proper order and proper way, then we do our job successfully. Okay? If we do everything in a proper order, then we can hit our objective and our target, something like that. Okay, regardless of what is your target and objective. Okay, as a human being, but all of us have its own objective and target. Okay, that's why we are working. Okay, so just like that, also in solving problems, everything has to be done in proper order so that we can solve properly the correct answer. Okay, for that particular problem. Get the point? Something like that. Okay. Number one. Okay. Given a data. Okay. Like this. Okay. 745 milliampere is a current. Okay. So let's put that as a capital I. Right? I is for current. Capital V is for the voltage. And R is for the resistance. Okay? The unit of voltage is volt, V-O-L-T. The unit of resistance is an ohm, and the omega, something. Or you just put just O-H-M. Okay? The reverse of ohm is the mho, M-H-O. Okay? And the mho is also equal to the Shemen, 1 Shemen. That's why we have Shemen's company, because their company is derived from the unit, the reverse unit of the resistance. Okay? And now we know. Okay, something like that. Okay, so the current is ampere, could either be ampere, milliampere, or any types of ampere if you want. For example, microampere, megaampere, nanoampere, because the prefixes in mathematics will always be used to simplify things further so that we can understand really to avoid a lot of zeros and figures when you solved something like that. Because you cannot memorize sometimes too much exponent. That's why we need to put mega. 10 mega ampere. Ganon. 2 milliampere. The purpose is for short abbreviation so that we can understand clearly to avoid putting a lot of figures and a lot of zeros of those data. Okay. V I is equals to ganon siya. So, voltage is equals to I times R. Okay? Ganun na. Ohm's law ni siya. V is equals to IR. Okay, and we have now already the I, the current, which is equal to 745 milliampere. Now guys, in my case, also, I have to convert this directly to ampere because the ampere is the standard unit in this topic with regards to electrochemistry or in practical electricity. So I don't have to use this milli thing, okay? I need to convert this to ampere first. Okay, now, 1 milliampere, what is milli all about in the algebra, basic mathematics? So if we start with DC, DC is 1/10 or 1 over 10. Centi is 1 over 100. Okay, milli is 1 over 1000. So therefore, we conclude that DC is equals to 0.1, something like that. 1 divided by 10. You have the calculator, something like that. Okay, and the centi is 0.01, something like that. Okay, and the milli is 0.001. Right? Through the prefixes in algebra and mathematics. So we can say, okay, 745 milliampere. Okay, so you will write the standard 1 milliampere in the denominator. Okay, so that you can cancel that out in mathematics. Okay, so 1 milliampere. Yan. So 1 milliampere, sa ganito kung diyaw-yaw ganina, 1 milliampere is 0.001 ampere. Because that is times to 10 to the negative 3. Okay, so 0.001. 3 zeros in left. Moving the left. Okay, because it's negative, right? The right is the positive. Okay, like ganon. Okay. Tanawa. Okay, so 0.001 ampere. Okay, ganon. So, 745 times 0.001. So, it will now become an ampere because the milliampere will be cancelled. Okay, so, ampere unit na siya. Okay, ganon. Calculator, please. Sarap. May ganon. Calculator, please. I cannot do this by my brain cells. Okay? Because there's something. Actually, we can move also the zeros, but I don't want because it take a lot of time. Okay? I think moving only, right? Because it involves zeros. But I want to make sure talaga. Okay, so 745, guys, 745 times 0.001. 1, 2, 3. Negative 3. Okay, milli. Okay, something like that. So it is now 0.745 ampere. Okay, like this. You get the point? Okay, so 0.745 ampere. Okay, ganon. Okay, then if you are not sure really, you will review also the prefixes ha. Okay, DC, centi, milli. Okay, then micro. What else? -6, -9. What is nano? Oh, yes. And then we have also the pico. Ganon. Okay? And then the other also side, we have positive also. We have another thing there also. Okay, the kilo, ganon. The kilo, the tetra, okay, the mega, okay, the 10 to the 8, the octa, okay, 10 to the 9, the nano, okay, 10 to the 12, we have the giga, 10 to the 9 giga, sorry. Okay, 10 to the 12, we have pico, something like that. Memorize that also, ha, the prefixes from 1 to 12, from 1 to 15. Okay, if there's a negative prefixes, we have also the positive prefixes from 1 to 15. And then somewhere along the way in the problem solving, it can be applied also. For example, 2 micrometer, and then you don't know what is micro. Okay, that is 10 to -6, ganon. And then 6, that is mega, and the positive equivalent, ganon siya. Okay? Just like this, milli. Okay? The equivalent of the positive in the milli is the kilo times 10 to the 3. So we have 1 kilogram. Okay, the prefix there is kilo added to gram. That's 1 kilogram. Ganon. That's why we have 1,000 gram because kilo is times to the 3. Okay? You get the point? Ganon siya. Okay. Ganon siya, no? So, 7.745 ampere na siya. Okay. Now, 8.56 grams of chromium. My goodness. Okay, this is the mass. Okay, 8.56 grams of chromium. Chromium is 3 positive. So 3 positive meaning it is having more electrons to be shared. Okay, to chlorine because we have a chromium chloride solution man siya. Okay, so this gonna be the weak pool of electrons. Weak siya because the chloride will pull more electrons from chromium. Because chromium has 3 positive meaning a lot of electrons will be shared to chlorine. Something like that, okay? You have to understand. Okay, now. So, chromium like this. And now, guys, we have the grams. Sa ganito kung gitudlo ninyo, if we see grams in a problem solving, what comes on your mind first is the molar mass or the density. Because the density involves mass in the formula. Okay? This is gonna be the basic always what comes on your mind. Okay? So if there's a mass, or it could be the other formulas somewhere out there, but later only because that is too complex to consider, such as the mass flow rate. Okay? But this is not talking about velocity and the speed of a substance flowing in a certain medium, right? So this is not unit operation. Okay, so all you have to do is to consider that density is equal to mass over volume, and then molar mass is equals to the mass of chromium over the number of moles of chromium. Okay? Always like that. And the molar mass is always equal to the molecular weight. Since we are dealing with one substance or one element only, so this is atomic mass. Okay, atomic mass is equals to the mass of chromium over to the number of moles of chromium, or equivalent to number of atom of chromium. Okay, because it's just only one element to be considered, something like that. Okay, so now you have, so let's just put this in this way. Okay, so atomic mass. Okay, atomic mass, or let's say molar mass only. Okay, actually the declaration only is the different, but we mean the same thing. Okay, like that. Okay, let's have to use molar mass because we are used to, for the purpose only of easy identification. Okay, but actually, to be precise and technical, this is supposedly atomic mass because single lang kasi siya, chromium lang kasi siya. It's not a compound. Okay, but for the purpose of discussion, to understand it more easily, because this is the term we will always use in science or in engineering, we will need to use molar mass. Okay, so molar mass of chromium. Okay, nagsabot tadaan. Okay, molar mass of chromium is equal to the mass of chromium, which is 8.56 grams. Okay, over the number of moles of chromium, in which we don't know. Okay, so we need to solve the number of moles of chromium, and we have now the molar mass because we have the atomic mass or atomic weight of chromium in the periodic table. Okay, something like this. This one. Tanawan na ninyo. Okay. So now, since I don't have periodic table at my end now, and I don't have a chemistry book either, I don't have also the Pyrrhus Chemical Engineer's Handbook either, I don't have also the physics book either, I don't have also the physical chemistry book either, I don't have also the thermodynamics book either, I don't have also the unit operations book either. All I have now to access is the online world. Then I have to Google. No choice. Because I don't memorize the atomic mass of chromium because that is not common already. That's already a transition metal in the periodic table. Okay? Ganon. So, I have to Google search that one because I cannot memorize everything in the periodic table also. Only the common. Okay? Like this. So, what is the atomic mass of chromium? Okay, I think 65 something. I don't memorize that because, but based on my memory recall, it's gonna be 65 something. But I just don't know. Let's just check the Google world. Okay, ganon. To make it sure. Sometimes we don't rely on memory if that is too much, right? We cannot be sure. Okay, something like this. Okay, molar atomic mass of chromium. Ganon. Atomic mass of chromium. Atomic mass. Okay, atomic mass of chromium. Oh, ito na. Meron siya talaga. Atomic mass of chromium is, oh my gosh. Okay. Actually, yung kalimti ang Avogadro number ha. It's always used in our problems. Okay? Ganun siya. Okay? Ganun na dyan. I-inject na yun sa inyong brain cells. Ganun. Okay? So, okay. Molar mass of chromium. Uy, may sulfate man din siya. Chromium chloride, magod siya. Sorry po. Okay. Pahit kining Google. Uy, usay mo, pataka yun siya. In fairness. And we need to investigate further. Okay, chromium 3, what is the molecular weight? Oh my gosh, molecular weight or atomic mass is 51.966 gram per atom. Okay, so we need to put now the 51.966 in the denominator. Okay, like, oh no, yes, in the denominator. Okay. Like this, this problem solved. Electronic industry, semiconductor industry, electronics industry. This principle and theory will be applied in the electroplating of various metal coating. Okay, so this type of topic, electrochemistry, electrolysis, because it's more on electroplating of the metals, highly conductive metals to produce electricity. So it's there you will apply this. Okay. But if you are working in another industry, this will not be applied also, but at least you have an idea. Okay, something like this. It depends on the industry you are working with. But if you are an instructor, then you have to project all topics, right? Because you are in the academy, you are an educator and a mentor. Okay, for all. Depends on the industry you are working. Okay, like that. Okay, now I have to put this in this way. So, number of mole, let's just use the mole in the purpose of discussion. So, number of mole of chromium will be equal to the mass of chromium 8.56 grams given in the problem over, okay, the Google search engine. Wow. 51.96996, okay, grams per mole. So cancel the grams, mole will be our unit. So divide this first. Okay, 8.56. Ganun. Drastic the guys off. Any questions so far for this? Okay, molar mass formula ka. Okay, so 8.56 grams divided by, okay, 8.56 divided by 51.996 is equals to 0.1646. This is our number of moles of chromium. Okay, ganon. Okay, ganon siya. Okay, now, okay, we have now the number of moles. And then, how long will it take the required time? The required is time in hours. Okay, like this. Time in hours. Okay, since in this electrochemistry, the standard unit is seconds, and we need to convert that in hours later. Okay, like this. So this is question mark. Time in hours. Okay, like this. Okay, guys, this one, guys. Ganon. Okay. And now, into the cathode. It's mentioned into the cathode. Deposited 26 gram into the cathode using a solution of chromium chloride. So, chromium chloride solution is used here. Now, you need to determine which is an anode and which is a cathode supposedly. But in the problem, it's being specified, so there's no headache anymore. It's already a cathode. Now, in cathode, what reaction takes place there? Cathode. We have the red cut. I told you, right? Red cut. Red cut meaning reduction, cathode. So now we have to put the reduction half reaction or reduction cell reaction. Okay, cell meaning the, the compartment of your electrical chemical reaction, something like that. So we have now cathode. So cathode, what's the happening in cathode? What's happening? There's a reduction. In reduction sa ganito, rega. Okay, rega. So rega gains in electrons. So this chromium, we're gaining the electrons from chlorine or chloride. Okay, because that is rega, that is reduction. So this chromium will become more electronegative, okay, as he accept or she accept more electrons from the chloride. Okay, so it's gonna be like that. Okay, so the reaction, since that is a rega, gain of electrons by principle, gain meaning plus, right? So chromium, like this, positive, 3 positive, plus, how many electrons can you gain from the chlorine? Okay, like this. So you will gain 3 electrons. 3 electrons, because the charge also is 3, okay, will produce chromium solid. This is gonna be the process, huh? The product will be a solid precipitate, okay, something like that. If you have the reduction reaction or the gain gani siya, guys, reduction automatic plus siya automatic in the reactant. Okay, okay, that's technique. If reduction, then it's in the reactant, then plus electron. Okay, then bingo, no more headache. Just try to remember that. Okay, so this one, chromium 3 positive charge plus 3 electrons gained by chloride is equal to the chromium solid. This is now in the cathode, existing in the cathode, undergoing the process of reduction. Okay, now, meaning to say, this is being reduced because it's going the process of reduction. Now, the one who caused this to be reduced is the chloride. Okay, like that. Okay, so chloride is the oxidizing agent, something like the reversed. Okay, so meaning to say, sorry, chromium is the oxidizing agent. Okay, makalibog, di ba? This is oxidizing agent ang chromium. Okay, you got the point? Because it is undergoing the process of reduction and it is being reduced, then it is an oxidizing agent. Okay, and then this agent leads the other substance to be oxidized. Other substance in the oxidation. Okay, the other. Okay, something like that. Okay, because if you talk about agent, talking about the other substance man. Okay, agent. Okay, you got the point? Okay, ganon. Okay, now, chromium 3 positive plus 3 electrons, 3 electrons equals to chromium solid. Now, this is now our stoichiometric relationship to solve what is being required in the problem. Just like in chemical engineering calculation or stoichiometry, we need to have the chemical reactions balanced, chemical reaction to solve what is being required. The amounts, the quantities to be solved, something like that. In here, it's just a matter of electricity thing or electrochemistry chuba chuchu. Okay? Now, take a look. In here, special. You need to balance the charges, oxidation number, and the number of atoms and the number of moles. Wow, bongga. A lot to be balanced. Okay, first, balance the number of atoms. Okay, chromium 1 balance. Okay, okay, this one. Okay, balance the charges. Okay, 0 like this and negative 3 plus positive 3, 0. Okay, so 0 reactants, 0 because solid guys exist as a solo element, the charge will be automatically 0. Guys, when an element exists as a solid, it will become neutral substance. Okay, neutral. If there is no charge, remember, if there is no charge putting at the top of an element, that is a neutral element. Okay, but it has a neutron particle because neutral. Okay, neutron coming from the neutral term. So that is neutron. So your neutron will be equal to the proton. When this chromium will be dissociated into aqueous solution in chromium chloride, it will become chromium 3 plus. Meaning to say, this chromium 3 plus will be appearing when you introduce or when you let this put in a chromium chloride solution. Okay, it will not become a chromium 3 positive if there is no solution. Okay, because it exists naturally as a chromium solid in which you found in the laboratory. Okay, the solid particle. So all solid particle you see in the laboratory that has a neutral charge. Okay, so that is a neutral element. Okay, if you can see in the laboratory, because it has not been reacted in the solution. Okay, but if it will goes in the solution, for example, 0.005 molar of sulfuric acid, so it's no longer a neutral particle. What I mean, it is still a solid. Okay, a particle. Okay, like that. Just like, for example, sulfur. I think that is yellow-green or yellowish color originally. If you put that in the flask or in the beaker, so that alone will exist as a neutral substance with a charge of 0. Okay, ganan. Okay, like that. You understand the point? 0 talaga ang charge niya, ha? Pag hindi mini-mention yung mga positive, negative, ganun siya, chupa-chucho. Okay, now, going to the, what is being required is the time. Now guys, since this is electrochemistry, in what equation the time will be involved? There's a lot, right? As I said a while ago, in power is supposed to work over time, right? Like that. And also in current is equals to Q over time. Q is the charge. We represented charge as small letter Q or big Q, but for me, in my own preference, I would like to represent the charge in small letter Q. But actually, it's just the same with the capital Q. But in thermodynamics, there's also capital Q. That's why I don't use the capital Q to distinguish in that thermodynamic aspect compared to this electrochemistry. So I have to put small letter Q, right? So it sounds reasonable enough to distinguish. But if you are really master, okay, then you don't have to worry in the declaration of the letter, okay, or nomenclature or any symbol or variable, whatever, chuba chuchu. Okay, now, time is involved. Arin lang kita mo base sa current because current is mentioned in the problem and good siya. So, current is equals to the charge over time in the discovery of Mr. Coulomb, a scientist named Coulomb. Okay, so current I, right? I, this is consistent thread I, simulat sa pole. I is equals to small letter q over the time. Okay, now we have the current mentioned in the problem. Okay, now we don't have the time because we need to solve that one, right? And we don't have also the Q charge. How can we determine? There are two quantities to be determined in order we can solve for the current that will pass through the cathode for this 8.56 gram of chromium. So two quantities, meaning we need to add more one equation to satisfy the relationship on how to solve in this particular problem. As the algebra speaks in mathematics, if you have two required quantities, then you have at least two equations or formulas to be used. But in here, there are two quantities to be solved. Then it is really expecting one more formula. Something like that. Or we can get that through tables, graphs like that, or certain, tables out there. So you can substitute directly. It depends, right? But most probably, equation and formulas will do. Dahil mga data kasi. Okay? Ganon. So, Q. Okay, and we solve now for time with this equation. So time will be equal now to time Q over I. Right? T is equals to Q over I. Now, what is Q? Q is charge. Now, what is the relationship of the charge into the Mr. Coulomb? Okay, what comes first in your brain cells is the Faraday constant in terms of Coulomb. Okay, then that will be your basis of calculation in your conversion factors to be inputted in your numerator. Now, use the Coulomb. Okay, 96. Ganun siya ha. Okay. For me, I don't want to use the conversion, the long one, because maglibog manggod ko. I will use really the formula. Okay, the appropriate formula, so I can really understand what's going on somewhere in my calculation. Because the conversion really is just only for good mathematics lover, high mathematical ability. But if you're just average, a little bit average like that, you are not really good in mathematics, then you go to the most understandable and comfortable for you, or through units. But in the solution through equations, I'll never use the conversion. Okay? Like that. I will use the answer like this and time you get the time. But here, I don't like that. Okay? Okay, it's not my preference also in solving problems. Okay, like that, going back. So Q 96485. That is 6.3 485 column. Okay, over mole dot electron. Now, this is your basis of calculation. Then go back to the chemical reaction in your cathode. Okay, so there is chromium 3 positive plus 3 electron is equals to chromium solid. Use this equation to solve. Okay, like that. Okay, now start with a column. Ganun siya. Okay. Okay, so times. Okay, I have to stress this one because in my 20 years ago, in my chemical engineering, or compared to now, Okay, so like that, because I researched, I read like, and really, I really found out, oh my gosh, it's gonna be like this. Okay, really, I really found out, oh my gosh, it's gonna be like this. Okay, so we have chromium 3, ano ba yun? Electrons equals to chromium solid. Use this equation, guys, ha, to solve this one, this equation in the cathode or in the reduction cell, okay, of your electrochemical reaction or electrochemistry. Okay, something like that. Now, we have the 96 columns per mole of electron. Now, how many moles of uh, electrons here? As I told you over and over again, guys, the coefficient of a certain number, certain variables, or certain element substances are the number of moles. It's not the number of atoms. Again, I always emphasize that in my discussion. Okay? Numbers put beside the element, the compound, the substance, or any charges, that is number of moles. That is not number of atoms. Because the number of atoms is equal to the coefficient times the subscript of that particular element. But there will be a time there will be no subscript value. You have to put that as 1. That's why it's still the same as your number of coefficient. Okay? So now, in here, your number of moles is 3 electrons. But your number of atoms is also 3. Because the electrons have no subscript. Okay, for example, if I will put 3 electrons subscript 2, so your number of atoms will be now 3 times 2. That is your number of atoms in electrons. But there's nothing. Okay, so 3 times 1 is just 3. Okay, so that is 3 moles of electrons or 3 atoms of electrons. It's just equal for that reason. Okay, so we have 3 moles of electron, and we have also moles in the denominator of our column. So put that in the numerator so that it will be cancelled later on. So 2 moles of electron. Okay, 2 moles of electron. So if you put that in the numerator, what will happen? These moles and electron will be cancelled all with the denominator in the column unit. Okay. What will be your denominator? In every 2 moles of 3 electron, okay, you will produce 1 mole of chromium solid. Because that is the one you try to find out. It's not the chromium 3 positive aqueous. Though it has the same also number of moles, but I'm only discussing you the proper way of identification. The chromium that we are trying to find out is not the chromium 3 positive here. It is the chromium solid because of the mass of 8.56 grams chromium. Meaning to say, it's already precipitated as a chromium solid particle. It's not in the aqueous. Okay, which means AQ. Okay, something like that. So, now we have 1 mole of chromium solid. Okay, 1 mole of chromium solid. Cancels now the mole electron, like this. And what will remain is the column per mole of chromium solid. Okay. Now, in my introductory part, I already solved the number of moles. Then substitute that here. Okay, because we have also 1 mole in the denominator times the number of moles. We got that already in the numerator. The moles will be cancelled. Something like that. You understand the point? Okay, where's that? It's lost. Oh my gosh. What's happening? Oh my gosh. Hello guys, what's happening in a computation? I computed that already, the number of, but not to repeat that again, right? Problem talaga siya. Fairness. This is very disadvantageous, right? I don't have the whiteboard to present my discussion, and then somewhere along the way, I need to find, where did I write that one? Okay? Oh my gosh. I have to find that one here. Nag-solve naman ko at number of moles, right? Okay, it's here. The number of moles is 0.1646 here. Substitute that there in your stoichiometric solution. Okay. Here, again going back. Here. Okay. Here, 0.1646 moles, multiply that here, okay? So that it will be cancelled out. So 0.1646 mole, okay, of chromium. Okay. Then, cancelled na siya, mole of chromium solid. Okay, so what's left here is the column. Unit of column. So it's still an electrical charge, but not yet that time. Okay? So, ganun siya. So, solve, calculator please. Ganun siya. Okay? So, 96485. Okay? 96485 times 2 times 0.1646 is equals to 31,762.862 column. Oh, let's just put capital C for columns, right? Okay, muna na siya. Okay, going back to our first formula that we are using. Okay, what's that? I need to find out. Okay, it's not really a headache anymore because this is now a direct substitution. Okay, our problem really is the analysis part. Okay, like this. Where's that? Okay, we have T over Q over I. This one. So time is being asked, right? So T, Q over I. And what is this column? Column is the unit of the Q or the charge of substitute directly there. So 331, 762.862 column. Okay. And what is your I? Guys, your I. Your I or the current. It's already solved also here. Current is 0.745 ampere. 0.745 ampere. 0.5 ampere. Okay. Unsa ganito siya? 1 column is equals to 1 ampere second. Okay, though the unit will be established here is column per ampere, since you know or we know that 1 ampere is equals to ampere second is equals to 1 column, then break that unit. Okay, so break. So column is equals to ampere second. Cancel the ampere in the numerator, so what will be left is the second. So your time now will be in second. And we convert that to hours, then bingo, we can solve what is being asked in problem number 1. Okay, let's check. Okay, 31,762.862 divided by 0.745. That is, my goodness, 71 seconds. But this is still second. It should be converted to hours because our time being asked is in hours. So, okay, how many minutes in seconds? So 60 seconds, 1 minute. Okay, basic, even elementary can solve. Okay, for this. Okay, then how many minutes in 1 hour? 60 minutes, 1 hour. So cancel minutes, seconds. What will be left is hour. So this is gonna be 60 times 60 is very easy. Multiply 36, then add 2 zeros without using the calculator. Okay, so divided by 3600, ganun siya. Okay, so our time will be 11.84 hours. Okay, to review again. Okay, we need to review again because I did not solve this prior to this discussion. We need to look for the real answer. Okay, like this. The real answer is, oh my gosh, what is that? Oh my gosh, the real answer is 17.7. It's here, right? So our answer is 11.84. Actually, it's wrong. Okay, it's wrong. But if the choices in the examination is very near to this, pick the very close answer to the choices. Okay, because 11.8 can be rounded as 12 hours, and 17.7 hours is almost the same, a matter of 5 hours only, but you have to review because 5 hours is very big. Okay? Like as I told you earlier, okay? We need to review. Okay? Because this is not, scripted. Okay? Okay, write only the problems and the answer in this paper again. And I did not solve while I'm vlogging. I did not solve ahead of time while I'm vlogging. Okay? So I solve on the spot. Okay, that's why. Okay, we need to review again. Okay, so this for me is not a challenge. Okay, to just to memorize the way it is being solved and you look for the solution first and you vlog. It's not like that. I don't like that one. Okay, that's why my vlogging it will take a longer time, really. Okay, that's the main reason behind. Uh, it's not scripted and prepared step by step. It's gonna be like this. What to speak. What's the second like this? Okay, so this is as what comes on my mind. Okay, okay, like that. So in here we need to review, so 96 for columns, moles for electron, times in the stoichiometric relationship. Okay, andiyan na naman tayo, no? Parati nilang ganun is like that. You need to have a lot of trials before your scientific research will be proven to be correct and tested, valid for everybody. Okay, it's gonna be like that, okay? So we need to review again. So 96,000 for 85 coulombs per moles of electrons. So we need 2 moles of electrons, 1 mole from solid electrons. Hala! Okay, it's gonna be like this. Okay, sorry guys. We need also to account pala siya the number of electrons. Hala! Yun ang sinabi ko sa inyo, no? Very quick, very quick. I really troubleshoot very quick. In our reaction of chromium 3 positive plus 3 electrons, okay, is equals to chromium solid. The 3 is the moles of the electrons, right? But the electrons also have 3 on the chromium, really. Okay? Aside from having a 3. So that is 3 moles of electrons. Okay? The number of electrons for the electrons here. Okay? So this 3. Okay? Hala no, di ba? Ang electrons. Atong ikalimatan. Okay? Because we are used to, in my case also, I am used to solve for only the moles, not the electrons really. Okay? Because this really a special topic as I told you a while ago. Electrochemistry is a special topic. Okay? It is not all the time being discussed. If it is being discussed, only very small, like this. It's not really rigid. Okay? But it's being discussed, sure, but it's not, what I mean is not being presented in a comprehensive manner. Okay, for example, examination only 1 item, 2 items, compared to other gases, liquids. There's a lot of problems that the instructors to be given during your engineering days or your students' days. But this electrochemistry is not really that common and popular. Okay, you will just give you 1, 2. Okay, and then it will not be registered to your brain cells if the instructors also will not give you so many examples or whatever, right? Okay, so like this. Okay, at least I know. Okay, ganon. So 3 times 0.1646, we repeat for the second time. Okay, like this. Just like balancing the equation, we need to repeat for at least 4 times so that it could be corrected. Okay, because we don't know, our chemical reactions are wrong and our production of our products are wrong, especially in the problem solving. The chemical reactions are not given. You have to write the chemical formula. You have to write everything. You have to write the chemical formula, you have to balance, like that. Good only if the problem stated already the balanced chemical reaction. That's very good, but it sometimes doesn't show that way. Okay, so like this. Okay, just like this also, right? So 96,485 times 3 times 0.16. Okay, like this is equals to, okay, divided by 360. Oh my gosh. Again, calculator problem lang. Sobraan og press. 96,485 times 2 times 0.1646. Okay. usahay, or in you first calculate it in the calculator is wrong, and then for the second time, maybe the pressure of your fan, something like that. Right? A lot of factors really that leads to error, right? You know, that's why. Okay, that's why there's no perfect human being in the entire universe. Okay, my gosh, no need to explain. Okay, oh my gosh. So like it's divided by 3600. Okay, like that times 2, right? Okay. It's 17.7. Okay. Hour. Sorry for that, guys. Okay. 17.7. Okay. Okay. Because in the reaction, okay, 3 moles electrons kasi nakaspecify doon. Okay. Wait. Wait. I have to show you again the reaction. Okay. Here. Here, right? Okay, 3 electrons man siya. Okay, so 3 moles of electrons of 1 mole of chromium man siya, diba? So like this. So muna siya natabo. Okay, hindi mo siya i-divide ang Q to 0.745, diba? So 17.7, the answer. Okay, 17.7 hours is the answer because your Q also will change because you already inputted the 3 moles electrons. It's not the 2. Okay? Like because we are referring to electrons, moles electrons. Okay? Like that. Got the point? So be careful. So my advice is be careful in looking for the stoichiometric relationship. So it really adds error. Just like this, I'm in error for the first time. Okay, the only way to know that you are in error is to, for example, if the problem is a multiple choice question, because it's not there in the choices. That's why you need to review again where you did get wrong, something like that. Okay, get the point? Oh, ganon. So it is 17.7 hours. Okay, for this problem number 1. Asa naman ito siya, guys? Okay, so 17.7 hours. Kaloka. Okay. Itong ibutang answer diri ha. Actually, pagliklik na ako, 17.7 talaga siya. Okay. Okay. First, sometimes second, correct? Because dissolve man o ganang diretso-diretso. Okay? Because I focus on the theory, concepts, and principles ng good siya. Okay? Like this. And also, I don't like also too much numbers. That's why. And I wonder why I become a chemical engineer, but engineer have too much numbers, right? So that it, so parang contradictory, no? Because they said an engineer is good at numbers, but I'm not really that good in numbers. That means I'm good in theories, concepts, and principles. Okay? Or else, if not 50-50, I will not become a chemical engineer, a licensed chemical engineer. Okay? So go back to problem number 2. Okay, problem number 2, the mass of the zinc are being mentioned. Anode and cathode are what we call an electrode. Okay, the anode will be your positive electrode or your positive terminal. Okay, your cathode will be your negative electrode or the negative terminal. So meaning to say pala, electrode and terminal is just the same in terminology in terms of electrochemistry. Okay, that's very clear. So in anode, what occurs there is the reduction process, and bingo, you can establish the reaction. Okay, so it's mentioned talaga siya. What if it's not mentioned, right? Okay, the mass of the zinc anode decreased by 1.43 grams in 56 minutes. Calculate the average current that passed through the solution. It's basically the same, right? Only the current is being asked. But wait, during this period. Okay, ganon. The only given is the time and the mass, and you have to calculate the current. Since again, time is involved, you need to use the I is equal to the charge over the time. So we have now a clue and hint in this particular problem in electrochemistry in a stoichiometric relationship based on the anode and cathode. It's always mentioned the time. Okay? So you will never use the plain Ohm's law. Okay, because we have also voltage equals to current times resistance, and there's no resistance at all here. Sometimes you need also to establish the unit, the quantity per quantity on the on the formula. So not only sometimes but all the time. Okay, because it's very clear time. Though the mass is not a column, then we have the column in Faraday, then we can play around the conversion factor somewhere along the way. Something like that, okay? As your basis of calculation. So in short, in electrochemistry, guys, basing on the anode and cathode chemical reaction, we will always have the basis for the Faraday constant, or Faraday number, which is equal to 96,485 coulombs over electrons mole. Okay, because in the reaction, also in the cathode reaction, there is also moles and electrons there. Then bingo, you can solve for the cancellation of the units, and you can convert, plus the basic idea of the molar mass. Okay, since in the molar mass there's the number of moles, then compute with the number of moles, and use that in your basis calculation again, and then multiply that, divide that, and to cancel the units, then bingo, you can solve for the columns. Since you know columns is equals to ampere per second, then break that up, then cancel the ampere in the numerator and the denominator. What is left is seconds, something like that, okay? Since you're going to find the current also, then put the unit, and then what's being cancelled, what's being left, then we're gonna chupa chuchu. Okay? Basta, you should always remember, okay, 1 ampere second is equal to 1 column. Okay, and if you try to play around the equation of current is equals to a charge over time, right? So charge is column and seconds is time is seconds, right? So column per second also is equal to 1 ampere. Okay, 1 ampere is equal to 1 coulomb per second also based on the formula. So based on the formula alone, we can detect the appropriate and the exact unit. And through that, we can play around the conversion factors in relation to stoichiometric relationship in the words. Tutuwaron pa siya, you can really solve. Okay? Like that. Because in here, if you don't take a reading, a research, a review for the first time, especially if you took this topic 20 years ago, normally you cannot answer this immediately. Sure, you can solve it. It will take you a very, very long time because you have to read, because it's very long time. Normally, and it's a biological process. No one can deny that. Okay? Get the point? Okay. Understanding what I meant. Something like that, for example. Also, acceleration due to life or increase. And memorize already, okay, which is 9.81 meter per second squared. Okay, 32.2 times density. Okay, the level of start memorizing in kindergarten and then going to elementary grade 1, a new complex, and then bingo, you can really understand what's going on. Okay, if you are very good at mathematics, high IQ of mathematics, then you will become a amateur. Just okay. But in the memorization part, through acquired intelligence, okay, through effort, okay, being sold, I buy reviewer like that. Okay, when I was in my review, I go to the library apart from my reviewer because I don't rely on center through online, something like that. Okay, so I don't for you in taking different features PRC. Okay, something like that. So you don't have to be dependent. Okay. The point, they can only give you a partial of their knowledge. If you have a knowledge of 80, they can give you only 40, 30, and the rest will be yours. Okay? It's gonna be like that. And that's why you need to take in advance learning for the next topic. So when the instructor will discuss a particular topic, and then you can topic. Okay, because all people have brain cells. Okay, so it's up to you how you utilize the brain cells that God gave to you. Okay, it's just that. No need to become intelligent, passed certain examinations. Okay. The preparation, adequate and thorough preparation. Because you will pass the and then you can add also aim, because if you will aim to pass, then more or less you will fail. Something like that. It doesn't mean that you are a consistent honor, you are a consistent business lister. Okay, like that. Okay, I'm telling you, I'm not a consistent dean's lister. Okay, I did not become a dean's lister when I was in fourth year, second semester, until in the fifth year. But I am a dean's lister when I was in first year until third year college students. Okay, extra element pa siya. There's no charge at all. But like this, the mass of the semester is the reduction, chemical reaction na siya. Because that's in the EQ solution naman talaga siya eh. Okay? That's why we put EQ, meaning EQs in the solution na siya talaga. Okay? But if the problem state like a zinc, that's a solo flight. Butang sa problem. That is still exists as a solo flight element, or as a solid or a neutral element. Okay, that is not or solid na siya. Parang ganun siya. This. So, 1.43. Blank sheet of paper and solve it yourself. Okay, like this, because it will take a longer time also. Okay, I have to sleep. So, okay, calculate the average current sa I. Use the basis of your calculation, the Faraday constant, 96,485 columns per mole, 485 columns. Okay, mole, electrochemical relationship in a chemical reaction could either be a reduction reaction or an oxidation reaction. Okay, ganun siya. Then bingo, you can solve what is being required over the number of moles. Then the number incorporated in your conversion factor somewhere in your Faraday constant as your basis of calculation. I is equals to charge over Q. Then convert that in seconds, then bingo, you can solve for the problem. Only the draft, what's that to do? The technique for this. Okay, it's gonna be like this. Okay, and then the rest will follow. Direct substitution. We don't have to use calculus there here because we are not deriving something, right? We are not using calculus. Okay, but in Arrhenius, Svanti Arrhenius, okay, we need to use the calculus. And in the Mekai less than 10 equation, enzymes kinetic, chemical reaction kinetics. And then in the Pugliese equation, the area, okay, of the integral, but you have to apply the calculus in that to obtain the equation. You need to derive too much, and then it will cost you time in the actual exam. Okay? And the important is you know how to correlate earlier during the examples of your instructors earlier during the examples of your instructors and examination. 3 books for I really bring a very big bag and from that place going to Tinanti of Nagasebo. Oh my gosh, every day too much load in my my manner of doing my study profile methodology of study, right? Okay, so from first year to fifth year it's gonna be like that always. Okay, and that is also books that the school. It's still another thing also. Okay, so too much talaga effort. Okay, so okay, I tell you honestly, it will just depend on your instructors and mentors and professors, and you don't consult books. I can say you will never most likely to pass certain examinations unless you are very very good in mental ability in the mathematics in the general engineering. Okay, because there's general engineering in all engineering courses, then others will follow also because theories guys have problem solving also. Okay, then if you are good in mathematics, then there's a chance because so many will come up problem solving also, something like that. Okay, theories questions also will come up in the examination. Okay, and then summa cum laude, that will never become a top notch. New trending questions coming in that particular year. For example, 2021 now, that is a new discovery from different scientists, modern scientists. If you don't read a lot, okay, in new reference materials in that particular year, you can never answer trivial questions. Okay, because theory questions are just happening in the Isaac Newton, the Arrhenius, but there are also new coming. Okay, sometimes also the PRC, a certain type of engineering course, and you cannot answer if you are not reading, if you are not watching news. Okay, if you are not referring to online new reference materials or books, then you can answer to that. Okay, so because the theory is obsolete already, this I discussed very obsolete. It's always keep on repeating. New generations will still repeating. New generations will still use this. After 2,000 years ago, me already died. Okay, because 2,000 na, di ba? So, I am now 100 years old. Still the generation, Arrhenius law, Isaac Newton's law, the law of, the oxygen, the nitrogen, the periodic table, blah, blah, again. Okay? And so I'm telling you, you need to have to adopt new modern technologies, theories. I'm gonna be like this. Okay? Like that. Because even though how intelligent you are, sometimes also if you are not encountering the terms, you can never answer also. Okay? Because IQ cannot help that already. Okay? For example, there's a new science discovery and you don't know that. Your brain cells cannot help for that because that's not numbers. Okay? That's not mathematics that you can solve through your own analysis in your brain cells. That's another term introduced by a certain particular new scientist. Okay? Then you cannot, if you did not read, if you did not watch that in the TV, in the newspaper, then you cannot answer, of course, normally. Okay? And then you will not bring newspaper in the actual examination. You will not bring data, mobile data in your examination. What is in there is only your hand do is to remember and memorize all those latest updates regarding science that is so like that and constant values because it will be used all the time, especially the pure substance water again and again. Okay, in in unit operations, really 101% sure. Okay, the gases like this, so that memorize all the constants for that, so that you will never be disturbed in actual. Okay, thank you so much for watching this live streaming, a very lengthy live streaming. It runs to 2 hours and 23 seconds. And if you like this video, you can comment down below in the comment section. If you are not subscribing at my YT channel, then it's about time to subscribe. But you have the full freedom to your voice regarding occupational safety and health, science, chemical engineering, physics, chemistry, all about pure sciences. And also musical segment, singing moment galore, okay, kahalad, fast beat songs, biritan, okay, and all. Okay. See you later in my next live stream, but I think I don't have time anymore. Thank you so much. My gosh, talaga. Very lengthy.